we don't need a little bit of territory to avoid starvation. We have most of the resources we need. Even in areas that are actually suffering from these things, we have ways to evolve to avoid conflict. So what they're looking for is some way to at least locally outnumber the enemy. Different ants are expected to do only certain tasks based on their capabilities. A war probably caused by the ego of a few particular people, sometimes some other explanation, but not the kind of natural explanation that you would find in the animal kingdom.
How does one get into studying ants?
Oh, well, that's actually quite a long story. It dates back to when I was around 3 or 4 years old, 1989 or 1990, and very often I would go out into the yard and watch the ants together with my mom, who's also a PhD in biology. We would take a look at all sorts of their behaviors, and then when she saw I was interested, she read me many, many books about these ants. So by that point, I already loved ants. A little bit later in the 90s, a game came out called Sim Ant, where you could actually control the ant in your ant colony. And by that point, ants had then become permanently one of my favorite subjects. So for the next 20 or so years, I would occasionally read some literature on ants when it came out, but I never really viewed ants as directly relating to my professional work. Much later, though, during my PhD, I thought, hey, I'm getting a lot of papers with various family members. Maybe I should try to publish a paper with my mother. And the topic that we actually had most in common by that point was ants, and in particular, ant battles. So besides ants, another thing that is one of my main interests is military history, all sorts of battles. And of course, that meant that that was one of my favorite things about ants to read about. And I realized that while there had been a few smaller articles about ants fighting, there hadn't been a comprehensive review on the topic. Of course, this was around 2012, 2013, and I had a lot of other things to do on my PhD and later my postdoc. But very, very slowly over the next 10 years, we gathered all these references about ants and put it together in a study. And I think that was assisted ultimately by part of what my research evolved to. I'll talk more about my research later on, but part of that research is computational modeling of various processes. And part of the review about ants kind of involves the same way of thinking how these ant battles develop, based on mathematical or computational models. So it actually ended up being at least a little bit closer to my actual research when we published it just a year or two ago than when it was very first started over a decade ago.
Wow. And so before the podcast as well, we briefly touched on that ant battles kind of intersect with how humans interact in their own wars. Why is that, and what are the intersections that you could share?
Well, humans are known for building a civilization, a society with many individuals that are part of the same group. And anytime you have groups, whether they're small or large, there's always going to be some form of conflict between these groups. Most of the time in the animal kingdom, it involves displays or very small skirmishes. But for a few species, most notably either very, very intelligent species like chimpanzees or species with huge numbers like ants, it can actually evolve to a full-scale war that is sometimes over a limited objective, but sometimes could be about the survival of the group. And ants, with their very large numbers, therefore, can be analyzed in a way very similar to how a lot of theorists started trying to analyze combat roughly around the time of World War I, using sort of mathematical models to predict what would happen. And in World War I, of course, there's formations of troops, sometimes some different specialists involved, certain linear patterns of warfare, the trench lines. In ants, you see a lot of the same patterns. Sometimes there's specialist fighters like soldiers or ants that can block the entrances to nests. The ant combat will usually be linear unless one group starts to have a problem maintaining that line. And that's actually a key aspect of ant combat that actually bears more in relation to more ancient human warfare. You can still see some parallels in the world wars. in ancient human warfare, everything was always about maintaining the line, maintaining the formation. You had these big blocks of armored warriors going after each other, basically. And that fighting was very fierce, but there tended to be very low death rates during that actual fighting. But as soon as one of them lost their formation, that whole side would rout. All those guys would run away, and that's when most of the deaths were. And you actually, to a certain extent, see something similar in ants. Ants won't worry and get scared and run away. But if they lose their formation, then another law of warfare comes into play. Because then you've got a few isolated guys not in formation, well, really girls because they're ants, battling the ants that are still intact. And that means you've got 2-on-1, 3-on-1, 4-on-1 fights where the one has a huge advantage. If they have that formation, well, then it's usually just a 1-on-1 fight. But without the formation, that's when many of the kills can happen in ant warfare as well. So this is one of the parallels between ants and human warfare. And there are many others. For example, the need to recruit enough soldiers to the battlefield and so forth.
Hey guys, thank you so much for making it this far into the podcast. If you have any feedback, then please let us know, as we always want to make this podcast better. So hearing from you is always a pleasure. Please subscribe to all of our platforms, get involved at Triangle Theory. If you've got any comments or if you want to share any topics that you think that me and Konrad would like to talk about, then please get involved. We'd love to hear from you. Thank you so much.
So you mentioned that it's only girls. Is there male and female ants, or is just one gender? Sorry, I'm not really sure about that.
Yes, so ants are kind of a little special because they're haplodiploid. Here's what that means. Most of us are diploid. We have 2 of each chromosome. But for ants, it's only the girls that have 2 chromosomes. The males just have 1 chromosome. That's what makes them male. So it's not like an X and Y chromosome with us. You've either got 2 of each chromosome, you're female, or 1 of each chromosome, you're male. And those males come from unfertilized eggs laid by the queen. Most of her eggs are fertilized. They produce the workers of the colony. Almost all the ants that you see are workers, but a small number of ants, the ones that usually have wings, they're the reproductive ants. Some of those are females, of course, but an equal number are males. So those reproductive ants are very precious to the colony. They will never get involved in any of these fights. They'll mostly just stay underground until it's time to do their mating flight. Then their only job is to go out and mate. And then the males will die right away, and the females will try to start new colonies. So most of the ants that are looking for food, tending to the nest and so forth, those are females, usually, though not always, sterile.
So what is the role of male and female?
So males, their only job ever is to mate, and then they very quickly die. Females, they do pretty much everything else. Some females, the fertile ones, also have wings, and their job is to mate and then become the queen of a new colony. But these are only a small portion of the total ants. Most of the ants are female worker ants, and they're what you most often think of as the classic ants, tending to the larva of the colony, expanding the nest, feeding the queen, going out and collecting food, and of course, fighting with other ants.
When thinking about ant warfare, why might one colony invade another?
There's a few different reasons, one of which is to eat the larva of the colony. Ants usually can't eat other adult ants because they have a tough carapace, not easy to digest. But the larvae are nice and soft and very nutritious. So very often ants will raid other colonies just to take the larva. In some situations, the ants aren't trying to defend their colony. They're trying to defend a food source. They might not even know where each other's colonies are. And then, of course, they're directly fighting over food. But very often, ants will actually raid another nest in an attempt to completely destroy or at least greatly weaken the nest, simply because that nest is close enough and therefore it's a competitor. There might be many situations where those ants have been fighting over food, or maybe their competitors have gotten to that food first. And so the ants want to destroy that colony because it's costing them too many resources that they might get themselves. Of course, when I say want to, I'm speaking a little bit anthropomorphically, but these ants, they're not quite thinking like leaders of a human civilization would. And this is actually one of the interesting things about ants. They have these very, very complex behaviors, but ultimately, these individual ants are quite stupid compared to a human. For humans, you can form armies, appoint officers, give orders in a chain of command. But for ants, well, there's no natural leaders or appointed leaders there. They all work through direct communication, chemical signals, and being aware of their surroundings. They need to make all of their decisions based on this. And this has a lot of interesting implications, both for comparison to human warfare as well as other subsets of perhaps future human warfare.
Sorry, how do they communicate? You mentioned by chemicals. What does that mean?
So ants have a very sophisticated set of chemicals that they can utilize. They'll have multiple glands, for example, so they can put chemicals on the ground. They can spray chemicals into the air. Sometimes they'll even use these chemicals as weapons against their enemies, but mainly it's for communication. And the coat of the ant themselves will naturally have some chemicals on it as it grows. And then meanwhile, the antennae of the ants are extremely sensitive at distinguishing all these chemicals, both type and amount. So this is one of the main ways that ants communicate with each other. For example, they'll lay many different types of chemical trails between, say, the colony and another point of interest. That could mean there's food here, that could mean there's a battle, and so forth. And then when ants find that chemical trail, they'll respond appropriately. Other ants might just be kind of following another ant, and this can lead then to large groups of ants moving along some of these trails. Other times, if chemicals get sprayed everywhere, that might be an alarm signal. So if a colony is under attack, this alarm signal, if a few ants spray it, then other ants will start spraying it, and pretty soon everyone in the colony will detect this signal and increase their activity, move to the surface, and try to get ready to defend the colony.
It's fascinating.
Do you ever see like colonies working sort of together in a sense? Colonies that were sort of maybe at war that come together. I'm just sort of thinking in sort of main sort of
not quite exactly that example, but there's definitely some interesting examples here. So ant colonies could be enemies, but there's many different levels of enemies. In some cases, they might simply each set their boundary and then they both respect that boundary, even though they're competitors. Minimal use of resources. So in some cases, they'll try to compete for every bit of food that's in between them. Instead of actually fighting each other over the food, they'll just each try to take it as soon as possible. Or they'll have ritualized battles where they're kind of standing up or making funny positions at each other, and then whichever one does better in that, usually the one with more ants, will then get to use the food, and the other ones will have to retreat. Sometimes they'll have small battles where they'll break off very quickly. Sometimes they'll have very intense battles over high quality food, and sometimes they'll have so many battles that they'll start scouting for each other and trying to destroy the other colony. Different colonies can move between these levels based on the situation. So for example, there might be two colonies that have had some small fights with a few dead ants over some good sources of food, but later on they become more threatened by a third colony. Then they're fighting less. They're not actually allies with each other. Ants can't communicate like that. But they're devoting more of their attention to this, and they're foraging and going to compete much less with each other because most of the ants might be busy with a more serious situation. So they can definitely respond dynamically to these things and change how they interact with other colonies over time. Now, there is a special situation for a few different types of ants that is particularly troublesome for humans, and that's called supercolonies. So these are different colonies of ants, and even though they're the same species, and even though others of this species might, fight with each other and try to destroy each other, none of the colonies in these supercolonies will fight at all. Of course, resources used by one still can't be used by another, but they don't fight at all. Very often, this is associated with polygyny. Sorry, got confused with another lecture. Very often, this is associated with polygyne colonies. Those are colonies that actually have multiple queens, and for these colonies, you can always have new queens coming in as the older queens die. So these ants that are not competing with each other, well, as you might imagine, this gives them a big advantage versus everything else. And that means they'll be very invasive. They'll destroy many other ant species in the area, and they can reach much higher densities and cause a lot of problems for humans. Some classic examples of this are invasive fire ants, which sometimes they can have multiple queens in a colony, sometimes monogyne, just one queen in a colony. And the Argentine ants are another invasive species that very often has these super colony forms that gives them an advantage over many native species of ants.
How
Fascinating. Sorry,
big are how big are those super colonies get?
Some of these colonies can be absolutely enormous. Thousands of individual colonies spread over many, many square kilometers. I don't know the exact sizes of these, but at minimum, many, many kilometers. Some, you could potentially even plot them on a map of the country and they'd be big enough to show up.
that's insane. Just another question as well. Do you find that ants compete a lot for the position of queen? Is there ever like internal disputes or like internal wars within a colony?
That's a good question. Usually, no. Usually the queen was there from the beginning of the colony, and she is the uncontested queen. So for polygon colonies, you could still have more ones coming in that are immediately recognized as the queen. But this isn't always the case. Ants, of course, have evolved to have very cooperative colonies where only the queen is the reproductive and everyone else supports the queen. This makes for a stronger colony. There's a lot of ants that, to a certain extent, can be in what you might call a more primitive state. They haven't evolved as strict a colony architecture. And in some of those cases, you can actually have some sneaky workers laying eggs and trying to have offspring. They wouldn't be enough to maintain the whole colony on their own. These workers, they were born in the colony. They never even made it. So these are unfertilized eggs. That means they can only become males, which are kind of useless except for the mating flight for the colony. But if workers can sneak in a few of these, that might give them a reproductive advantage. And in some colonies, this is what they do. But in these colonies, they often try to police each other. So if they see workers developing their body to start laying their own eggs, they might just kill that worker. Doesn't always work, but it's what they'll often try to do. There's also another situation. If you've got a strong colony and the queen dies, well, then that colony doesn't have much of a future. It's not going to last too long because soon all the workers will die and then the colony will be over. But when the queen is dead, that changes sort of the chemistry of the colony. And now it's much easier for the workers to start developing their own reproductive system and laying some eggs for sort of, one last chance to have a few reproductives in the next mating cycle, before the colony disappears due to lack of new individuals. And even in this situation, the ants will very often fight over, who gets to lay the eggs. So there can definitely be some major competition within these colonies too.
Will ants sort of eat other ants' larvae, sort of if there is that sort of competitiveness?
In this situation, yes. If the workers are policing each other, they might eat the larvae that kind of aren't supposed to be in the colony. Or when the queen dies and things become chaotic, well, then it's sort of an everyone for themselves, almost between the workers that are starting to develop their reproductive systems. In this case, they're kind of less eating those larvae for nutrients and more eating the larvae to try to kind of gain the competitive advantage for themselves, though of course the nutrients help. But usually in a colony, they're not eating larvae for nutrients. Sometimes the queen might eat some of her own eggs that haven't developed that far if she needs to reclaim some of the nutrients if the colony is not doing so well. And I believe there might be some colonies where some of the eggs are kind of designed to be some nutrients that are fed back to the queen. But usually this kind of competition within the colonies doesn't happen. It's either on a very, very small scale or only in very special situations.
It's fascinating. I've seen like a couple of like ant warfare battles as well, and it's pretty like brutal. I also saw that, and correct me if I'm wrong, that ants sort of almost risk their lives for the betterment of the colony. So you'll see like a lot of the time like ants using their bodies as a way to, I don't know, benefit the war in itself. Is that like a true thing?
Absolutely. Ultimately, evolution tries to optimize behavior so that there can be more copies of those genes in the next generation. So imagine that from the worker's ant perspective. Except for very special situations, that worker ant will never have any offspring of its own. But the offspring of the queen are very closely related to the offspring of the worker. So if the worker does anything to help the queen have more offspring, then those genes of the worker are still going to get passed on. So that's why, ants are somewhat unique in that they evolve completely selfless again, except in very special circumstances, completely selfless workers that will, sacrifice everything for the colony. That doesn't mean they're smart about it. That doesn't mean they're not smart about it, though. For example, a new worker, that just came out of the pupa, it has a very soft shell, and it still has a soft carapace, and it still has a long life ahead of it. So these workers are usually not going to be ones that will actively sacrifice themselves. They'll usually stay in the nest and tend. As the workers get older and older, they spend more and more time outside the colony. The oldest ants have the most dangerous job, the foraging job, looking alone for new food. And when it comes to battles, it usually is mostly the older ants, with their stronger armor, that are participating in the front line and have, less to give to the colony in the future. But this is actually something that can make some aspects of ant wars very different from human wars, because, those ants, they're not going to break their line until they're absolutely physically forced to, because they're willing to sacrifice everything for the colony. When it comes to human warfare, imagine the ancient Greeks and Persians fighting, or the ancient Roman armies fighting with the Carthaginians, or the Chinese and the Mongolians. Usually these battles ended when part of the human army, got very worried and ran away. And the interesting thing is, very often, the best human armies were the ones that acted most like ants. As we discussed
Wow.
earlier, in either of these battles, if the line breaks, that's an extremely difficult situation that usually leads to a big defeat. So the human armies that kind of did the best job at suppressing their own soldiers' instincts for self-preservation, which is absolutely an instinct in humans, because we're not part of a colony. The ones that did that would have the humans that would run away the least, and therefore be most victorious in these battles. And to a certain extent, psychologically, humans know that their best chance in these battles is not to run away. The ancients knew that that's when most of the casualties happened, but it's also absolutely animal instinct to run away when there's a big problem. So suppressing that is completely impossible, absolutely, but you can still get it to a lower level than in other armies. And that's why there's some very famous soldiers, like the ancient Spartans of the Greeks. They did lose some battles, but they were known for being extremely disciplined. They would run away at much, much higher threshold than many of their opponents, and that's what brought them many of their victories. They basically acted more like ants.
With also like battle formations, do you ever find that ants do sort of recon, or sort of trying to understand how the other colony works prior going to war, and then feeding that back to the colony?
To a certain extent, distance from colony is an absolutely critical aspect in ant battles. And the ants are always going to try to record this distance as well as they can to try to produce more successful results. For example, imagine you're a big ant colony and you want to crush your competitor over here. But, you can't just send every single ant in your entire colony there. That's simply not how the ant colony, works. And the further away it is, the harder it is for ants to get their recruitment mechanism to that point. The ants that leave the trails need to go back and forth many times, and that takes more time. And this might mean that even though a colony is larger and more powerful, if the fighting is happening closer to the small colony might actually be able to locally bring more troops to bear and to be victorious.
Wow.
So ants need to sort of take this into account when making their decisions on whether to fight. And the way they do this is that each individual ant is sort of keeping track of how many of their friends are nearby, how long the trail is, and all that kind of goes into the algorithm of how that ant is making a decision. And together, that will then determine whether the colony will conduct an all-out war or perhaps something else.
So like it will weigh up its decision on like risk, essentially.
Exactly.
Wow.
The ants have very complicated mechanisms that are certainly not fully understood to make these decisions as a collective whole.
Do ants sometimes disobey?
Well, it's not quite disobey, because remember, these ants are not getting orders, but there can definitely be ants that are not doing what theoretically should be the correct thing. Ultimately, an ant is still not able to perfectly synchronize with every other ant and get all the information available to the colony. the ant might see only a narrow piece, and that might...
Hey guys, your feedback is very important. And no, this is not an advertisement. Actually, what I'm asking from you is to leave a comment below what you liked and most importantly, what you disliked about this episode, because we can improve on the next episodes and we can make a better content for you to listen. Give us also a topics you'd like to us talking about, and we can prepare, do your research and talk about it on the next episodes. Thank you.
Tell that particular ant that it should be doing something that, from the whole colony's perspective and from most of the other ants' perspective, the ant should not be doing. That definitely happens. The ant system is not perfect. Almost no communication system is perfect. And ants, even though they're very algorithm-based, are no exception for that. And in fact, they can get confused in different ways than us. For humans, sometimes you can send a nice, simple message. It can be received by everyone, and that's it. But ants don't have this language to communicate. So like I said, they might only see their small area, and that might be telling them to retreat or to attack more aggressively, or that they're no longer even needed in this fight, even though that might not actually be the case.
When when a colony is at war, will ants sort of, let's say in the situation where the colony is attacking and they're not doing so well, will they conjure up sort of reinforcements to sort of keep pushing?
All depends on the situation. If they're fighting over a food source that's of sufficiently high quality and sufficiently close, that makes it more likely that they'll try to summon reinforcements and win. But if it's much further away or not as good quality, then there's a lower probability that more reinforcements will come there and the ants might end up retreating. When it comes to the ant colony itself, they're usually going to try very, very hard to defend that colony. But eventually, they might sense that they're facing an overwhelming force. For example, the army ants. So army ants, they live in colonies, but they don't live underground. They're huge, powerful groups that move over the jungle floor, eating pretty much anything in their path that they can catch. And that could even include large animals if those animals are not able to move fast enough. And other ants are one of the many different things that these guys prey on. Sometimes they can even attack other very, very large ant colonies. That's how powerful these army ants are. And, they're not trying to completely eliminate the colony. They're moving around so much, it might be a really long time before they ever get back to that spot. But all that delicious, nutritious larva, that's what they're going for. So an ant colony, if they're facing an overwhelming army ant attack, they might actually try to, well, of course, they'll try to fight it off. But if they can't, they'll try to evacuate the colony, ideally taking with them as much larva as possible, but hopefully at least the queen, and then wait for the army ants to clean out everything they might want of the nest, and then go back when the coast is clear. And the threshold of fighting to the death versus evacuating, that's something that each ant, to a certain extent, needs to determine based on its local surroundings. So some ant species might always run away. Other ant species, like huge leafcutter ants, if they can react fast enough, they can often stop the army ants. So it's really a very dynamic process that depends on all sorts of factors. Sorry, what were you saying?
Where do they evacuate to? Because if they leave their own colony, where do they make a new one?
So this can vary, but very often they'll just be on the surface, far enough from the colony to be out of the path, ideally, if they evacuated to the right spot, of the army ants. Usually they won't have prepared backup burrows or anything else. They're going to be exposed on the surface. They'll all be highly alert and still able to defend against other threats, but it's definitely a very risky maneuver, especially with the queen on the surface and needing to move too.
I mean, if they're going back to the ant colony once the army ants have sort of taken their larva, might they be sort of at risk of that kind of thing happening again?
Usually army ants won't go back to the same spot right away. These ants are, moving somewhat chaotically over extremely large areas. Every now and then they might retrace the same route. So if the colony is directly on the route, it's probably going to end up destroyed. But usually this colony would be on some side branch that maybe the army ants wouldn't even take next time they came in that area. So these colonies might be okay in the longer run, especially as they get more time to grow into a larger colony that's more able to withstand these army ant raids.
How long does it take to build an ant colony for them?
Well, as little as the first year after the new queen comes in, they'll already be a recognizable ant colony with a queen and several workers. But it usually takes at least a few years for that colony to get to roughly mature size. And it's not until that point that the colony starts producing more specialist ants, which include the reproductive ants. So the colony itself, definitely goes through a maturation period. Colonies that are very, very young are extremely vulnerable. Most of them do not survive.
It's amazing. I just wanted to go back to the sort of warfare, sort of envisioning an epic sort of ant battle. When sort of looking at sort of formations and holding the line and maintaining that, my ants use sort of warfare tactics like trying to outflank or other sort of battle strategies in order to sort of win the war, so to speak.
Absolutely. So for some background in that, if the ants can at any point in the line outnumber their opponents, then that's when they'll be able to start actually killing their opponents more rapidly and gaining a battlefield advantage. So what they're looking for is some way to at least locally outnumber the enemy. And if the enemy has just a complete line, it's very difficult to do that. But what each ant will do is, they'll move to the battle, and then very often they will move toward the flanks. And that means that if they can outflank their enemy, they can move to the flanks faster than their enemy colony is, then on the flanks, there won't be 1-to-1s. There'll be more 2-to-1s and 3-to-1s. So, getting around that line will absolutely give them an advantage. Ants, of course, don't always have to completely work in two-dimensional space. Ants can crawl over each other much more effectively than human soldiers, right? So kind of outflanking over trying to get into the rear areas might also be a tactic. This is often why instead of seeing, a perfect line of ants in some battles, you'll see two big masses, which are somewhat fighting on a line, but there's also lots of ants waiting behind the front to be involved if other ants try to crawl over. If they weren't waiting behind the front, then crawling over the front line and attacking from the rear would be a devastating tactic.
I've seen a lot of it where they sort of even on the front line they'll all sort of go over the top of each other and then sort of try to come sort of from the back almost.
Exactly. But if there's sort of, a big patch rather than just a front line, that will become more difficult. You won't be able to break the line by crawling over or piercing it like that.
Yeah.
And this does have some analogies to human warfare, not crawling over the heads, but of course, in ancient armies, you didn't just have one or two guys behind the main soldiers. You had a thick block of soldiers. In a Greek hoplite phalanx, for example, usually there would be at least 7 guys behind the leader, and in some tactics they used even more. It was for the same basic reason. You can break that line via any means, you've got a big advantage. And if you've got more soldiers behind, that will help prevent the line from being broken.
Yeah, I also was reading also this other sort of battle formation and why the Nazis were quite successful taking over France was even though that their army wasn't as big, they just sort of went all in really quickly and overwhelmed their opponent with such force that they did it very quickly. Do you find ant colonies doing the same thing? Like even though they might be less in numbers to the other colony that they might be sort of invading for, let's say for fruit or for larvae, do you think they sort of go for that sort of overwhelming sort of tactic?
Absolutely. This kind of blitzkrieg tactic is exactly one of the possibilities I described for the army ants raiding the nest.
Yeah.
So leafcutter ants are one of the most sophisticated types of ant colonies. They're the ones that grow the fungus gardens. They've got ants of all different sizes for all different jobs. A mature leafcutter ant colony is a very difficult opponent. But the leafcutter ant colony on its day-to-day basis has, lots of ants out foraging, lots tending to the larvae. There are, of course, sentries, but they're not always going to be ready for a strong sudden attack by the army ants. So if these army ants are able to pull off a blitzkrieg, find some entrances that are poorly defended, and then pour in there quickly with a huge amount of soldiers, just like the German breakthrough in Sedan in France during World War II, well, then the leafcutter ant might lose a lot of its larvae and its queen, even. If the leafcutter ant, gets enough notice, then it can respond quickly, it can block these, and then it's kind of classic siege warfare where the big leafcutter ant colony might be able to perform quite well since it's got, those specialized soldier ants.
Do you notice, have you seen that in your work, that ants who went through a battle, they evolve their strategy and try to do something different next time?
That's not necessarily something I've seen. I didn't encounter any kind of long-term adaptive battle plan for these ants. Remember, to a certain extent, that would require some memory for these ants.
Hmm.
And so that's difficult. Each of them is sort of like an automatic input in, decision out with just the local inputs rather than longer term memory. Ants, there are certainly some that where the colony can sort of, I don't want to say remember, but be influenced over a long term for something. But I'm not sure if anyone has actually investigated battles for that. Other than certain relations with other colonies, they might remember what that relation is and how aggressive they should be. But I don't think they'll think, oh, we tried too much the outflanking maneuver here. Next time, let's just try a rush directly through. I don't think ants are quite sophisticated enough to do a sort of plan like that. Even though they can adapt their battle tactics on the fly, they're not going to have like an after action conference and decide to do something different next time. Now, on a larger scale, of course, if ants encounter something new in their environment, like a new species, then over time, that species of ant can certainly evolve to deal with that new situation in a more optimal way. But that, of course, is over a much longer period of time, many generations at minimum.
What is the lifespan of an ant?
An individual ant, it can vary quite a lot. Usually it's at least a few weeks, and several months is more typical. I think in rare cases, some worker ants might be able to live a few years, but I'm not completely sure about that. Queens, of course, will live quite a bit longer. It's quite typical to see healthy colonies with queens living 6 or 7 years for some species, and other species maybe even a little longer than that. But I couldn't tell you the record or anything like that.
Yeah. You go for
Sorry,
it. Go for
no,
it.
no, you go for a comment. Sorry.
Okay. You mentioned as well, I wanted to go back a little bit because you said that when the queen dies, the colony becomes a bit chaotic. So how do they then go and choose the new queen?
So in that case, for some species, it is possible for a new queen to show up and then be immediately accepted because they are actually a new queen. But most of the time in that situation, there is no new queen. That colony is on the path of desolation. There'll be no more new eggs laid that become workers, and eventually all the workers will die, and then there simply won't be a colony anymore. So this is why, some of the workers in some species might be then desperate to lay a few more eggs to make some reproductive individuals for the next reproductive cycle, because after that, there's simply no more colony. Of course, when that colony disappears, there'll now be a patch of ground that is being patrolled a lot less. This would be a great place for a new colony to land and will have a much higher chance of surviving, not getting quickly eliminated when the colony is small and vulnerable.
Could you remind me the word again when it's one queen and a few queens? Is poly and mono? Something like that?
Monogyne and polygyne.
Polygyne and monogyne. Okay. So those colonies that have multiple queens, where do these queens come from?
Usually they'll come from other nearby nests. In fire ants, for example, that make these super colonies with the polygyne form, not with the monogyne form. Usually the queens will simply walk to a nearby colony, and they'll be recognized as a polygyne queen then and allowed to go into that colony. So even though some of the queens each year die, a few queens come in, and thus these colonies can actually last a very, very long time, even though 5 years after it's first started, probably none of the original queens will survive, because these polygyne queens, they're actually smaller and less healthy than the monogyne queens. Monogyne fire ants could be 6 or 7 years before they die. Polygyne, they could probably only live 2 or 3, but there's a constant influx of queens that should be able to keep the colony healthy for a longer period.
When sort of going to sort of the army ants that sort of live on the top surface and stuff, do they sort of also seek opportunities for expanding the colony, or if they see another colony that they could flush out and take over that, so that the existing colony could move into something? Do you normally see that they're trying to sort of also harness the landscape to sort of steer a population outcome to be more successful?
So they do absolutely harness the landscape, but not quite in the way you're thinking.
Okay.
These army ants, they don't need to have an underground colony. Their lifestyle is, they camp somewhere new every night.
Yeah.
on the surface, but there's just so many of them and they're such strong ants that usually no one is going to mess with them. But they're not just moving randomly. There's certain channels and terrain that they will keep clear to allow them easy and fast movement, as well as a few side branches for other scouting and raiding. And then the whole colony is kind of moving just slowly, but there's a whole bunch of scouts and raiding parties going in and coming back. To a certain extent, even non-army ant species will have some of these paths that they maintain for their normal foraging routes that are maybe even somewhat protected, like a little underground debris on the side, allow the ant to move around a little bit more safely before you can forage. Army ants, they even have guys sitting along the edge of the trail to protect the column. They've got guys clearing debris out. It's really quite an industry and a very intricate process how this colony is moving and foraging and attacking all at the same time.
I've read that some ants enslave other ants. How does that work?
It's all in the chemistry. So remember how I said that ants use various type of chemistries, both on their own body and chemicals they can deposit for all of their communications. If an ant encounters the wrong chemicals, it can become very confused. A funny example of that is that usually ants will move their dead to graveyards, well away from the colony, hopefully to avoid disease. But if you take some of the dead ant chemical and put it on a live ant, the ants will also move those outside the colony to the graveyard. And that ant will keep trying to come back, but then it keeps getting moved to the graveyard until the chemical disperses. So this shows how their behavior can be completely controlled by certain chemicals. The slave makers ants, they will snatch other ants in the larvae stage. And then those larvae will get tended to in their own nest where they're exposed to a completely different set of chemistry, but a set of chemistry that is designed specifically to make them be part of that new colony, the slave maker ant colony. And then they will respond to that new chemistry. The slave makers themselves have many specialized chemicals, partially that can override their behavior or mimic the chemicals of their original colony and make them think that they're actually part of this new colony now, and that's where they need to be serving. It doesn't always work. Every now and then, you might get a slave revolt if, this concoction of chemicals didn't go quite the way the slave maker ants wanted. But of course, the slave makers are highly adapted for this, and that means that most of the ants that they take as slaves, will be good slaves for them. Of course, slaves to a certain extent is maybe a little bit too much of a human word here. They're called slaves in the ant world simply because they're serving a colony that is not, the colony of their queen. It's not like the other ants are directly giving them commands that they have to answer in a way that they wouldn't in their original colony. They're kind of doing the same thing in their new colony, more or less, that they would be doing in their old colony. Their chemical loyalty is just different. But, calling them slaves does, to a certain extent, have a basis in reality, and I think is a very, catchy way that can let people understand it. So this kind of terminology has, stuck around in the field, even though it's more like chemical brainwashing.
Yeah, I know you mentioned that ants not necessarily disobey because they don't have orders, but I read somewhere, and correct me if I'm wrong, that these enslaved ants sometimes not necessarily disobey, but attack their slave masters, let's just say. Is that true?
Absolutely. Those chemical concoctions, both on these ants and, on all of these slave maker ants, need to be just right for these ants to not naturally recognize them as an enemy. These slave maker ants, they might normally be successful, but there's a lot of evolutionary pressure to fight back against them. And sometimes if the ant has been, for example, receiving less of these chemicals or not quite the right makeup, they might realize what they're supposed to be doing and attack. So sometimes you can almost get these slave results that can actually destroy the slave maker colony. It's very rare that that happens, of course, but it has been observed to happen for sure.
This is
So interesting.
It's just so fascinating.
Sort of looking at would you say with ant colonies that the main sort of goal of an ant colony is to sort of go to war, sort of cause these raids? Can an ant colony sort of live in harmony without sort of having to use sort of violence or sort of battles to sort of get an advantage?
Absolutely. Ultimately, ant colonies, like almost all other animals, are evolved to maximize the creation of more ant colonies. And sometimes that can mean all-out war, but sometimes no war at all. There are many ant species that simply don't go to war. They have other ways of working out their problems. For example, if they do have some kind of competition over food, instead of actually fighting, they might have ritual combat where the ants will kind of stick up their abdomen or hold a funny pose or clink their mandibles, their mouthpieces in a certain way, and that will then determine who gets to eat the food. Or they'll simply establish a boundary with another colony, respect that other colony, and then just not move into each other's enemies, not move into each other's territories. Since yes, maybe there's good food there, but once you start disrespecting the boundaries, then well, maybe you'll get more food, but you'll also lose a lot of your colony to various fights. In that case, it's just more efficient to not fight. So there are plenty of species of ants or individual ant colonies, within some species that just elect, not to fight in most or all circumstances. And they're still able to do perfectly fine. Obviously, they would defend their colony, and obviously they would fight back if someone attacked them.
Sure.
But they're just evolved to not be aggressive toward others, and they can still be very successful because sometimes that allows them to save a lot of resources.
Yeah, exactly. Might you find that sort of doing that sort of ritual first and, going through that process before just sort of going, do you know what, it's going to attack and, we might lose people, we might not. Do you think there's more of a benefit to an ant colony that has those systems in place?
Absolutely. And in fact, it's not just ant colonies. There are so many groups of animals that have evolved ways to minimize the amount of fighting and try to resolve the conflict without fights. It's not just the ants, it's also, our closest relatives, the chimpanzees, some animals like meerkats, many other groups of predators. Sometimes these will fight, but very often, most of the time, in fact, at least the local conflict is resolved without any violence, or at the very least without any injuries. So usually this is the more efficient thing to do. Certainly not always, which is why you see the full mix of strategies. But a lot of the time, peaceful coexistence is the best strategy.
Yeah, so it's just amazing because it's something that, sort of looking at our, let's say, as a human race, it's something that we could sort of definitely take more, looking at and not having to conflict with each other if we don't need to.
Absolutely. I mean, humans also have, actual ability to do advanced diplomacy, which, overall is very useful. But then again, with the complexities of human civilizations, there's also more reasons to go to war than animals will often have, unfortunately. So that's why you still see a lot of wars. But it's maybe not quite as bad as you would think. If you look at death rates in human societies, even compared to older human societies from the last century, compared to primitive human societies, compared to our closest relatives, the chimpanzees, the death rates in humans in modern times are lower. So yes, there's still a lot of stupid wars, but at least more advanced civilizations have reduced those, even if we haven't gotten to the point of eliminating them.
So true.
I'm just curious to hear your opinion as well, because we can see that there's wars in other kingdoms of other animal kingdoms. So do you think war is a natural occurrence or is something that, because a lot of people say, oh, humans are so greedy, they always want more and they're constantly in wars. But when you look in ants, for example, they have wars. So is there something that is just in nature, is just how it has to be?
Well, I think there's a couple different ways to answer that question, and I think they're both quite valid. Unfortunately, to a certain extent, wars are a natural process. That's why we see so many of them in these species. From the perspective of the colonies going to war, on average, they might gain more from the war than they lose, and that means evolution will shift behaviors to try to create wars in those situations where usually they would gain more than they lose in the wars. That doesn't necessarily mean that human wars, or at least many, many human wars, should be thought of as natural processes that derive from these animal instincts. For ant wars, of course, ultimately human behavior is governed by, human free will and actions, right? That's a very, very different process than the means by which ants go to war. So many of the fiercest, worst scale wars that we see in the animal kingdom are not related to whether war in human societies is natural. Now, you can still look at our closest ancestors, their closest relatives, the chimpanzees, and yes, they also do have war. Sometimes individually very brutal war. I mean, you can arguably say that these chimpanzees have free will. They're very intelligent creatures, not as intelligent as humans, of course, but very intelligent. And yes, evolution has produced outcomes that sometimes make them go to war. They do much prefer less violent methods. Most conflicts between groups of chimpanzees are not resolved by an actual war, or even by minor skirmishes that result in death. But sometimes they are. These instincts that are making the chimpanzees go to war, though, these are usually not the instincts that make modern humans go to war. Yes, if you're talking about humans that lived perhaps 100,000 years ago, okay, then yes, the parallels between those humans and the wars they no doubt fought may have been very similar to those of chimpanzees. But in the 21st century, we've got in most places of the world a lot of food. We don't need a little bit of territory to avoid starvation. We have most of the resources we need. And even in areas that are actually suffering from these things, we have ways to evolve to avoid conflict that are not war. So most of the famous wars in the history of humans, if that's not a society that needs to go to the war to avoid starvation, then that is not a natural war. That's a war probably caused by the ego of a few particular people, or sometimes some other weird explanations, but not the kind of natural explanation that you would find in the animal kingdom. Again, I'm not saying that this is the case for all wars in humans, but certainly the world wars, certainly wars that are the ones that caused mass deaths and not just small scale things. So I would say those wars are very uniquely a human phenomenon.
Um, the other day I saw a video on Reddit where a scientist filled an abandoned ant colony with cement, essentially to reveal how it looked like in the past. And they found that they have like chambers, tunnels, ventilation systems. That's something that I wanted to touch on, ventilation systems, why they have it and how they know that they need to have it.
Well, it's all based on instinct. So ants, again, they have very sophisticated sensors, and that means they'll know if something is not well ventilated enough. And, of course, these ants, they need oxygen just as much as other animals. If they don't get that, they're going to start to suffer health problems. Further, there might start to be growth of fungus or other things that could potentially damage the ant colony if their colony is not properly maintained. For example, if they detect that something is starting to go wrong in some of the chambers and it needs to be ventilated, then their instinctual response will be to start, digging upward or to start connecting it to other existing ventilation pipes within their colony. So even though these ants have these very sophisticated architectures, it actually very closely follows patterns that are based on individual ant responses to stimuli.
That's
Also wanted to ask, just for my own curious brain, is it true that there can be a fungus that can develop on an ant's brain where they can turn on each other?
Absolutely.
So it's almost like a zombie ant, essentially.
In this case, the fungus it's not quite something that makes them try to eat the brain of another ant, like the classic human zombie.
Sure.
But it does substantially change their behavior. The fungus managed to evolve a very sophisticated mechanism to change ant behavior by, to a certain extent, growing into the ant. And again, ants, they don't have super complex mechanisms for their behavior. So the fungus, if it has a lot of time to evolve with the ant, can manipulate the ant behavior quite precisely.
Wow.
It tries to get the ant to spread its fungus to other ants, but also just to spread it in general. So the ant might move to a high place before the fungus blooms, and then the spores can go around and infect other ants. It might try to make the ant visit another colony. It might make the ant kind of tap a lot of other ants in its own colony. If the other ants in the colony detect this fungal infection, then they might fight back and try to get rid of the fungus-infected ant, of course. So it can definitely cause some conflict. And these kinds of fungal parasites or other parasites that infect insects and change their behavior, it's not just the ants. There's many other insects that can do this. And in fact, there are even parasites that can change the behavior of more sophisticated animals. For example, there's something called Toxoplasma gondii. I might be mispronouncing that, sorry. But this toxoplasma, its main host is in cats, but sometimes it can get to mice. And when the mice are infected with this, these mice will start living on the dangerous side, hanging out to where they might smell cats, for example. So that's a fairly sophisticated animal and a fairly precise behavior, and these parasites are still able to alter the host behavior. It's possible that this toxoplasm can even somewhat alter human behavior.
Yeah, I was going to say, can it work its way up to a human host?
It's not necessarily specifically evolved for humans. It's mostly specialized around cat-related stuff. But it can definitely affect other animals too. I don't know the details of exactly how it might be affecting humans.
Yeah, no, it's just interesting. So I read that sort of fungus can have that effect on ants, and it's not just that particular fungus, but fungus is quite like a common thing that can happen where it can grow on them or within their systems and stuff like that.
Yeah. Many different types, actually. Some that can have multiple hosts, some that are specialized on some different types of ants, and of course, other insect hosts.
I've seen one of the defensive mechanisms of ants that they sometimes explode themselves to defend the colony, to kind of release some sort of chemicals. That reminded me, it'll be just a bit off topic, but have you ever watched Dragon Ball?
Dragon Ball. I know that's an anime, though I don't think I've seen any episodes of that one.
Anyway, there was an episode where this guy called Vegeta exploded himself to kind of defend the Earth. So that was kind of the relation that I saw. But how does it work? And how do they do that?
Well, this goes back to the self-sacrificing ants. These ants in particular have certain glands with this very toxic substance. But when it's contained inside the gland, well, then the ant is kind of safe from the contents. On the other hand, when there's lots of enemies coming in, and then the ant can potentially sacrifice itself to potentially take down several of these enemies. And then basically that gland will rupture and the whole abdomen of the ant will rupture, which will then hopefully cover as many of these enemies as possible, allowing maybe the other ants in the nest to rally the defense.
So when they explode, do they release some sort of like acid onto other ants, or is just like it works as a bomb? Like how does it work?
So it's not a bomb. It's they basically explode a fluid. I don't think it's acid, though I'm not 100% sure on that. It's a fluid that's extremely toxic to other ants, though. So it's more like a chemical warfare, basically, like a poison. And when that poison gets in contact with other ants, it starts, causing them very big problems. I don't know the exact mechanism of those problems, though, but it might in fact have multiple mechanisms. Some neurotoxicity, some direct attack on the cells, and so forth.
Sorry, just to ask this question as well. Like from everything that you sort of studied on ant colonies and in your research, what's like a benefit that you've seen in colonies that could transfer to human behavior?
Well, I think these colonies, even though to a certain extent the ants work for the colony as a whole, the way they do it is still, at least to a certain extent, takes into account the welfare of the individual ants. For example, if an ant is having trouble or lacking food, well, that ant is still an important member of the colony that contributes to the whole colony. So others of the colony would be willing to give this ant some food. And yes, that has a cost to the colony, but in doing so, this ant will still be part of the colony for at least some time in the future, and will still therefore be contributing to the colony, even if only indirectly. The other is over the division of labor. Different ants are expected to do only certain tasks based on their capabilities and based on their physiology. Like the young ones that don't have a hard carapace, they're raising the larva. The most dangerous tasks are done by the older ones with a harder carapace. So even though each ant is adapted to contribute to the colony as a whole, the colony is also trying to arrange jobs to take care of the individual ants and try to make sure that each of them can be as productive as possible for a very long time in their life. That I think is something that maybe human societies could do a little bit of a better job in. There's a lot of humans that might be having trouble and unable to support themselves, but in at least a large number of these cases, that's only a temporary situation. These things could be fixed, and pretty soon that human could be back at work, benefiting both themselves and everyone else in the country that they're part of.
Yeah, it definitely seems. Yeah, like from what I've tried to understand and read about in colonies, it's definitely like sort of for the benefit of the colonies, not so much like the individual, so to speak.
Yeah. And I think that, countries, sometimes perhaps the amount of care we give to citizens is less than it should be, but let's at
Mm.
least get it up to the optimal level for the country, even if that might not be, all the way up to, a perfect, completely compassionate level, but this seems like the minimum bar that we should all be able to accept. And very often the actual level is below that. So to me, that just seems like a very important step in improving human society. And I guess I've also got, probably a less important, to me, somewhat relevant part of that question. So ants, they're very organized, and they do this by following certain standardized rules that are kind of built into their behavior and produce these logical outcomes. Sometimes I think that, laws and regulations should be, rather than so many minutia, kind of specify more direct input, direct output, simple to understand, what needs to be done kind of thing. So maybe instead of pages after pages of complicated laws, these can be simplified while producing actually a slightly more optimal result, just like we very often get in ant colonies.
What is something that you the most fascinated about your own research and when you're studying ants?
Sorry, I'm a little unclear on that question since you said my own research. Do you mean my gene drive research and how that relates to ants, or are you asking something different?
Just like when you're researching genes or ants, what is something that you really fascinated about?
Well, I suppose one of the things that kind of most tickles my imagination is all of the different subclasses of ants within the ant colony and how they all have certain special tasks. The simplest, of course, is you've got your queen in every colony, you've got your reproductives in any colony, and you've got your workers in every colony. But in the colonies that sort of are most personally interesting to me, there's many, many different types of workers. Some workers are called major workers, or colloquially known as soldiers. So very often it's these soldiers that are involved in a lot of the fighting. And the specializations of these soldier ants just really fascinate me. Some of them have like the big heads that block the ant nests. Very often, this is critical to avoid a blitzkrieg of your colony. Some of these soldiers just have really big jaws to crush all in their path. Others are actually not for fighting other ants at all. They're for fighting mammalian predators. So these guys have really big, really sharp jaws that will even make, a human say, ouch. And in fact, these soldiers, if you line them up in a human wound in just the right way and then chop off the head, leaving only the head there, can actually act as sutures for a wound. Some South American cultures practice this, quite effectively for a long time. And, you've got all sorts of other soldiers with these interesting tasks. And it's not just soldiers, there's also different types of workers. Like the leafcutter ants, they've got these really teeny guys that are responsible for taking care of the fungus garden and will often use chemical warfare against the bad fungus that's trying to take over from the good fungus.
Is there ever a pecking order in which there are ant colonies, sort of on the status or on the job role or anything like that?
Not directly. These ants, they're never giving orders to each other.
Yeah.
Yes, they all do require different amounts of resources. Like these soldiers, for example, they're very valuable ants simply because they're larger and therefore more resources have been put into them. So, they're not always equally employed for all tasks. In some cases, the biggest soldiers might just be sitting around most of the time getting their food directly delivered by medium-sized workers. But it's still not a pecking order because ultimately these soldiers do have some important tasks. As soon as it's time for them to defend the colony, they'll be on the front lines, often dying the most in that situation, protecting the others of the colony. So, at first glance, some ants might look lazy, but that's actually by design of the colony. We risk the important ones when they have an equally important job.
Just to touch a bit on your research, the gene drive, how is it different from gene modification?
Gene drive starts with a gene modification. We take an insect and then we give it a new gene or a set of genes. So that's gene modification.
Could you just touch on how does it work when you give them a different gene?
This is actually multiple methods, but I'll tell you one of them that uses CRISPR-Cas9 technology. The nice thing about CRISPR-Cas9 is that it lets us precisely cut DNA. So the idea is that we get some insect eggs, and then we inject those eggs with a very, very thin quartz glass needle that contains a mix of a bunch of stuff. And some of the things in that mix are Cas9 and guide RNAs that will precisely cut the genome exactly where we want. And then we have another little circle of DNA that's designed to be inserted into that cut. So then we basically have precisely targeted a certain piece of the genome, and we've added our new DNA exactly where we want it to. So this is one of several possible ways to do a genetic modification, to do a knock-in, add new genes to the genome. You could also just make a little cut and break some DNA. You don't have to add new genes to where you're cutting, but in this example, we do. So far, maybe we've added our gene drive to that site. But so far, it hasn't done anything special. It's just like any other genetic modification. So now that insect grows up, and now we've got insects that have this genetic modification. We usually add a fluorescent protein. So these insects have, a glowing red or green body or eyes. So we know which one will have the modification that we added. So now here's where the gene drive comes in. So let's say we've got these insects with gene drive, and they're going to mate with insects that don't have gene drive. And we've all got, 2 of each chromosome, right? And the gene drive insects, the gene drive is only on one of their 2 chromosomes. So usually in the next generation, after these gene drive insects mate with the regular insects, usually half of the offspring would then get this DNA that we added. Simple Mendelian inheritance. We have 2 of each chromosome, and we pass on just one of those to the offspring. Gene drive, it changes that inheritance. So if we've got a gene drive, even if the gene drive is only on one of the 2 chromosomes here, and it mates with this wild type normal insect, if this is a really good gene drive, it might be that all of the offspring get the gene drive. So this means that the gene drive has increased in frequency. And the way that it did that is that it copied itself. So remember how I said we cut a gene, and then we had a special plasmid designed to be inserted into that spot? Well, a homing gene drive works the same way. You've got the gene drive chromosome, you've got the other chromosome. We cut this other chromosome, and then it uses the gene drive chromosome to repair itself, and it makes a copy of the gene drive. So now instead of just one gene drive, one wild type chromosome, we have 2 gene drive chromosomes. No matter which one we pass on to the offspring, it's always going to have a gene drive. So in the first generation, maybe we have 1 gene drive. In that next generation, maybe we have 2 gene drives. In the next generation, we have 4 gene drives, and then 8 gene drives. So in just a few generations, the gene drive will increase in frequency. If we then released these insects into the wild, just 1% of insects, which is not too difficult to do, it's easy to grow a lot of insects in the lab. Well, then in just a few generations, which is maybe just a year or 2 for some species of mosquitoes, well, then everyone can have the gene drive. So imagine we do this in mosquitoes, and we add on an extra gene that's part of the gene drive. Just like we had a gene that makes the mosquito's eyes glow red, which isn't needed for the gene drive, but is together with the gene drive. Now let's say we have another gene that prevents the mosquito from transmitting disease.
Yeah, I was just about to ask.
Malaria or dengue. And then we just release 1% into the population, and now all the mosquitoes have this. Now they're safe mosquitoes. They don't give us disease anymore.
I got dengue fever once. So when you said that, I was like, my God, imagine having a mosquito that doesn't contract malaria or dengue. That would be insane.
And to a certain extent, we already know a lot of genes that can prevent transmission of these diseases. Dengue is one of them. Malaria is one of them. These are still active areas of research, and other scientists are coming up with even better ways to stop the mosquitoes from transmitting disease. But we already have some pretty good candidates for this. We just need to make a gene drive that will work as designed, which is a lot harder than people thought it was 10 years ago. But my lab and other labs are making quite good progress on this. And there's something else you can do with gene drive. For this, you don't even need a special gene to prevent disease transmission. You just need to have a good target gene. So if we were to precisely put this gene drive inside a female fertility gene, Well, then at first, most of these insects would just have one copy of the gene drive, and both the males and females would still be spreading the gene drive, increasing its frequency. But pretty soon, we're going to have a lot of gene drive. And then we're going to have females that started out with 2 copies of the gene drive. And any female that has 2 copies of the gene drive doesn't have any good copies of her female fertility gene. So those females will be sterile. They won't be able to reproduce, and therefore the population will go down. It might even be eliminated. So this is another way we can prevent mosquitoes from transmitting disease. Of course,
Could remove them altogether.
exactly. Well, not all the mosquitoes. There are actually thousands of different species of mosquitoes, and most of those, if not quite our friends, are not the really nasty ones that spread disease. The nasty ones, there may be only 10, maybe 20 if you count some more minor ones. So some people have considered making these mosquitoes extinct as another way of stopping disease transmission. And so far, making a species extinct always worries me a little bit. But it's thought that most of these species that are good at transmitting disease to humans are human specialists and are not an important part of the ecosystem and might actually be overpopulated now compared to how they were 100,000 years ago, since they're human specialists, and humans, there's a lot more of us now than 100,000 years ago. My lab and some others does work on gene drives that can be confined to only certain populations. They won't copy themselves. They use other more complicated mechanisms. So we do have kind of safer methods that could still be really good, if not quite as strong as the strongest gene drives. And these might be particularly good for invasive species and agricultural pests. Not quite as important as malaria that kills over 500,000 children every year, but still very important. We were talking about fire ants and Argentine ants. One of our recent papers showed that gene drives might be pretty good for fire ants, even though it would take a while. So we want to eventually use gene drives to go after these other targets as well, even though our lab is mostly focused on mosquitoes. And I want to say that even though we're thinking about the agricultural targets, I'm actually doing this because I'm an environmentalist. What I would like to do is get rid of the agricultural species in the farmland, not in their native area, of course. And then the farmers won't have to spray nearly as many pesticides. So, they'll both save money and less off-target effects on species that we care about.
Yeah.
So I'm really hoping to, over the next few decades, use gene drive for all sorts of conservation purposes, after we deal with those mosquitoes.
Yeah.
Do you just focus purely on insects, or you can do gene drive on any sort of species in the world?
So my lab focuses on insects, and especially mosquitoes, though we do have a couple other examples and collaborations. There have been a few other labs that have made gene drives in non-insect species. Some of the earliest gene drives were in yeast, but more relevant to actual applications, some people have made gene drives in mice and rats, which normally are an important part of the ecosystem, but there's all sorts of islands where those things are just devastating all the local species. And there's also been gene drive in plants. So far, just your model organism plants, but hopefully that's the first step toward fighting a lot of invasive plant species.
Jackson,
And
that
we're
was...
also working on invasive fish.
share more about it.
So this stuff isn't fully published yet, though we have announced it at a few conferences. But there's all sorts of invasive fish, many of which were put into ecosystems by people that wanted to fish them, and they didn't realize that this might not be such a good idea for all the native species living there. So we've been trying to develop kind of an example gene drive in fish to eventually be a stepping stone toward these non-model fish that are causing problems. This is another collaboration. So gene drive is certainly the most advanced in mosquitoes and a little less advanced in other insect species, but several groups are already working on these future applications. So I'm very optimistic. I imagine that not all of the problems with these species can be solved by gene drive, but gene drive can at least help with a lot of the problems, maybe even a lot.
Yeah, it'd be amazing to see, like a gene drive in like a lionfish where it stops devastating coral reefs or something like that. Would be pretty incredible.
When creating this sort of technology, what was the biggest challenge in doing so?
Well, the biggest challenge is probably resistant alleles. So remember how I said we've got that CRISPR-Cas9 technology that precisely cuts the DNA and then usually that will then copy in the other gene drive. But sometimes the cell doesn't copy the gene drive. Sometimes it just puts the chromosome back together and it changes the sequence a little bit. And when the sequence is changed, can't cut it anymore. And if we can't cut it, eventually it will probably have a fitness advantage over the gene drive and outcompete the gene drive, especially if it's a suppression gene drive. But for modification gene drives, it could be very bad as well. So these resistance alleles have been seen in some of the earliest gene drives, but over time, my lab and other labs have come up with ways of dealing with these resistance alleles, either preventing the really bad kind of resistance or at least, getting rid of the resistance alleles that are usually not as difficult. Usually we will need to combine some methods to deal with these, but some of the latest gene drive designs have been much more promising about avoiding bad effects from these resistance alleles. So that's why a lot of groups think that we're starting to get a lot closer to using gene drive in some of the worst mosquitoes, hopefully within the next several years.
Wow. Jackson, thank you so much for coming on. Jackson, where can people find more about you, your work, and everything you do?
Well, my website will have a very brief introduction to gene drive, as well as some news about the lab and some papers. People are definitely welcome to check out some of our reviews. You'll also find the link there to the review about ant battles. Let's see, I can send you the link
that would be incredible.
This website.
We'll definitely share that in the description. But Jackson, thank you so much for coming. That was incredibly interesting. I learned so much more about ants and the gene drive, and really appreciate for you coming on.
Thanks again for inviting me. I'll email you that link, and have a good day.
Have a good day.
Thank you, Jackson.